Technology is influencing the way we do things, and metaphysics of artificial intelligence is evolving, projecting a new paradigm in developing new artificial intelligence digital platforms. These AI digital platforms enable engineers and software developers to design the next generation of smart robots and intelligent bionic systems. Machine learning coupled to artificial intelligence methodologies will help humans to provide technological solutions in healthcare, business, military, robotics, and bionic applications. Develop software algorithms using object-oriented programming in C++. In this segment, I illustrate several intelligent digital platforms. Each digital platform is based on integrated artificial intelligence algorithms residing in firmware. The objective is to develop neural artificial intelligence systems in robotics, medical solutions, industrial applications, and bionic cyborg engineering. Semiconductor integrated circuits are also developed to complement neural intelligence designs based on nanometer technology. All semiconductor artificial intelligence RISC processors are developed based on system-on-chip ASIC design methodologies. Artificial neural networks. Neural networks feed forward back propagation network for supervised or unsupervised learning. Neural networks learn by example. They have been used in applications ranging from autonomous vehicle control to facial recognition. Artificial neural network is a computing model inspired by nature. It is a methodology to mimic at a certain level the way the brain stores information and reacts to various inputs. When a neuron is excited by a stimulus and becomes active, it sends a small charge along this network, which in turn causes other networks in the network to become active. In software-based artificial network, neurons and their connections are constructed as a mathematical relationship. When the software is presented with an input pattern, it feeds this pattern through the network, systematically adding up the inputs to each neuron, calculating the output for that neuron, and using the output to feed the appropriate inputs to other neurons on the network. Weights are important to determine strength of connections between all neurons. As a general concept, hidden nodes, learning rate, momentum, and initial weight all work together to optimize the network for learning effectiveness and speed, while minimizing certain pitfalls that are encountered in neural network design. A lower value of learning rate results in a slower training process but reduces the likelihood of the network going into an oscillation. Bionic engineering with artificial intelligence, deep learning, and applied neuroscience. Artificial intelligence neural network algorithms. The basic strategy in implementing a neural network as a high-level program is to establish a framework of data arrays to hold the weights and to track accumulating totals as signals are fed forward and errors are fed backwards through the network. The nuclear layer and molecular layer of the brain consists of cells. These cells are represented in complex software mathematical algorithms as perceptrons, as I have illustrated in this video. A sequence of nested for loops iterates through these arrays, making the various calculations required as the backpropagation algorithm is executed. Software algorithm and process initialize the arrays. The weights are set to random numbers. Begin a large loop that runs the system through a complete set of training data. Randomize the order in which the training sets run on each iteration to reduce oscillation. Calculate the hidden layer activations, output layer activations, and errors. Back-propagate the errors to hidden layers. Update the weights. If the system error is greater than the success threshold, then run another iteration of the training data.